Okay, so we've got this large, awesome data set here. It's not nearly as large as the original, but we do have 80 variables, 16,000 plus students. So that's quite a bit of data. Our goal here is to pick a base year variable, so a variable from when the student was a sophomore in 2002, as well as a third follow-up variable. So when the participant was, well, it would have been it would have been in 2012 when the participant would have been about 26 years old. And what we want to do is pick some kind of interesting combo of base year variable and follow-up third variable that would make a cool relationship. So we want to see perhaps if something in the sophomore year of high school students either predicts or perhaps even causes some outcome 10 years later in their mid-20s. And this is a nationally representative data set, so we can find some, if we find a pattern, it generalizes to the entire US population, at least of that age group, so people who are now about 30. But probably, unless it's a variable that's changing rapidly, probably we can tentatively generalize it a little further than that also. So how do we do this? Let me tell you a little bit about some of these variables, and then I'll show you how to look up things that you'll need to do. So this first column here is student ID, and that just each student in the data set's given a unique ID. Don't worry about that. That's more for just researcher practice. I kept that in there. Next one is a student weighting. Again, don't worry about this too much. What it is tells you how many students in the population of about 3 million sophomores in 2002 this particular student represented. Now, why aren't these numbers all equal? That's a great question. If you're interested, let me know. I'd love to discuss it further. It deals with representing minorities and different sampling strategies. So feel free to ask me if you're interested. Next one, we have sex. So this is base year sex, male or female. We have 2s and 1s, and we can quickly guess that those are probably representing males and females. But which are they? So if we want to take a look at something like that, we would just copy that, go into the codebook file, paste it. We may have to click around a little bit until we get to the place where it says name and then has our variable. Now, typically you'll reach it faster than I did just there, but keep going until you reach the variable you're looking for in the name position. After you do that, there's two important parts. The description tells you a little bit about it, gender of student. This one's fairly straightforward. Some are a bit more complicated, but it tells you where they're getting that data from. And then down here we have a little table that tells us the different outcomes that we could have on that variable. So 1 here is male, 2 is female. These are really important, this -8 and -4. What these are missing data. So whether the student was supposed to skip it for some reason or they just didn't respond, we need to kick these values out of our regression. If we leave this -8 and -4 in the regression analysis, what will happen is it'll just assume that these data points are all ordered, and so it would be like a extremely super male is what it would count a student with one of these values as. Because notice 2 is a female, you go down a little bit, you get a 1, so then the regression doesn't know how to distinguish that, so it would just say, wow, well, we're just continuing to go in that male direction several more steps to get our non-respondent. And point being, we need to get rid of those missing data, but to do that, you'll need to know what different values each variable has that you choose. And this is how you would do it, using this category chart. And then, of course, you can sort them and take those out. So going back to this, we have race. Now, race is an interesting one. So let's take a look at this. Race and find. Notice this isn't quite the variable I'm looking for because it's by race R. Here's the one I'm looking for. And it gives a little information on how the race was determined, whether or not they reported two races. This one's pretty detailed. It's the opposite of the gender, which is one of the least detailed. And then it gives us the different categories of races. Notice that here we don't have a meaningful scale. Like as we get higher, we get stronger in some quality. It's not like as we go towards 7, we get more or less racial. So this is what's called a categorical variable, and we'll talk later about how to handle something like that. And again, notice we have these missing data down here. What else we have? Date of birth, so the year and month. This is generational status, whether they were native US born or first or second generation, how high of education the mother had, how high of an education the father had, the grandparent, income of the parents here. SES is a nice one, socioeconomic status. It actually accounts for income, occupational status, and education of the parents. This is the students' expectations of how far they'll go in school, and so on. Reading scores, standardized math scores, how good they are at math, how good they feel they are at English, how they feel about the school, whether or not they were in soccer, were they in a solo sport, a team sport, the highest level they got in a sport like varsity, or were they just reserve, or were they actually a team captain? Let's see. Were they from urban, rural, suburban area? Can't quite remember what some of these are, but again, all you'll need to do is grab it. And what I would do, I would recommend opening both windows at the same time, so you can just grab, paste, find, let's see. Okay, so here's the variable we're looking for. So first friend is Hispanic. Isn't that an amazing level of detail for the data set? So this tells us whether or not the student's best friend is Hispanic. Now that might be interesting too if this person is Hispanic or if they're not Hispanic. So you could look at that, whether or not they have the same race for their best friend. What do we have here? First friend is white. Okay, and I accidentally left that in. If you see something with -5s all the way down, that's a restricted variable, which means we do not have access. You have to go through a large process, chain your computer to a desk. It has to get all this, kind of think of the NSA, CIA. You have to go through something remotely similar to that because this is incredibly sensitive data. To us, it's just numbers on a page. But remember that each one of these rows is a student, is a life, an identity. It talks about their children, their wife, their zip codes. If you have the restricted data, you can identify people in this data set. And that's powerful information that should only be in the right hands, which is why you do have to go through security checkpoints to get certain variables. Now, why they restrict whether your best friend is white and not Hispanic, I'm not sure about that, but that's be an interesting point of discussion. So then you go out here to the F3 variables. Now these are the results, the things that you're trying to predict with your base year variable, or potentially show that the base year variable is causing this. So we have, did the student ever drop out of high school? Did they ever attend a post-secondary institution? If they're currently employed, how satisfied are they with their job? Notice that you will have to factor out the people who are not employed, and you'll get that by looking up the codes for the different values there. Their socioeconomic status when they were in 2012. Notice this is the student's socioeconomic status, and this original one was the parents' socioeconomic status. So I'm going to do that. I'm going to look at how well does the student's well, the student's parents' socioeconomic status. So high school student, their parent, their wealth, prestige, education, how well does that predict what the student will be like 10 years later? How strong is the correlation between those? So what I would do is just grab that, cut it to clipboard, paste it in a new sheet, and then I'd go back to, just a second, okay, go back to this larger data set and find that variable I'm going to predict, cut that to clipboard, and paste that right there. And now I'm going to run the regression analysis on these two. But before I do that, I'm going to have to clean the data.